All right, folks, it's back in action here. In this video, we are going to develop the formulas to find the sum of the interior angles and the exterior angles of a polygon. You'll notice that I've already filled in some numbers here for you. You can fill those in here in just a little bit and verify those with our formulas after we've developed them. So we're actually going to start here at the top, and we're going to develop our formula 100% based on triangles. So if we look at this chart over here to the right, we've got a triangle here at the top that has 3 sides, and of course a triangle has only one triangle, and we know that the angles add to 180. Now what we're going to do is we're going to look at 3 other shapes to develop our formula. Starting with our quadrilateral, we're going to come over here and look at this quadrilateral, and what we're going to do is we're going to choose one vertex, doesn't matter which one, draw in all the diagonals from that vertex. So I'm going to connect to here, breaking this quadrilateral down into 2 triangles. Back to the chart, I can fill in then that there are 4 sides. It creates 2 triangles, and that's going to give us each triangle will have 180 degrees, and that'll give us a sum of 360 degrees, which is a number that most of you already knew, that the sum of the angles in a quadrilateral was 360, but you probably didn't really know why. Now let's take a look at the pentagon, a number you probably also know, but let's understand why. We're going to look at our pentagon. Again, we're going to grab a vertex, draw in all the diagonals from that vertex to break this down into triangles. And now we can see we've created 3 triangles. Back to the chart, we have 5 sides in the pentagon, 3 triangles that were formed. So each triangle will have 180 degrees, and that will give us 540 degrees. Again, a number that you probably already knew. The hexagon, you may or may not know. Some of you probably do. So we're going to look at the hexagon through the same process. Pick one vertex, any one that you want. Draw in all the vertices or diagonals from that vertex. That's going to break my hexagon down into 4 triangles. So go back to the chart. I'm going to have 6 sides, 4 triangles. So each triangle will have 180 degrees, and that will give me a total of 720 degrees. Now what we want to do is we want to come up with a pattern, because trying to draw a shape and always have a shape handy for all of our other polygons is just going to be too cumbersome. We want to look at a relationship between the number of sides and these number of triangles. On the triangle, there were 3 sides and there was 1 triangle. Our difference was 2. On the quadrilateral, 4 sides, 2 triangles, a difference of 2. Pentagon, 5 sides, 3 triangles, a difference of 2. And the hexagon was 6 sides, 4 triangles, and a difference of 2. That pattern is what will be able to hold true for all of our other ones. Our heptagon will have 7 sides, and it will have 5 triangles. You can check that at 5 triangles times 180, you will get 900. Continuing, the octagon has 8 sides. It'll have 6 triangles. 9 sides will have 7. 10 sides on the decagon will have 8. The undecagon has 11 sides. It'll have 9. The dodecagon will have 12 sides. It will have 10. And again, you can verify that this number of triangles times 180 will in fact give you these totals that I've written here. Beyond the dodecagon, we are not going to have a name for our polygons. We'll just call it an n-gon based on the number of sides, and we've done this before. So an n-gon will have n sides, and the number of triangles will be n minus 2. So following the pattern of what we've been doing, we can express this as the number of triangles times our 180 degrees. That is the pattern and the formula that you're going to use for the sum of your interior angles. We can summarize that formula in one other way. Some students prefer to put the 180 in the front and multiply it by the n minus 2 that way. You don't really need to distribute it though. I would keep it as it's separate so it's a little easier to remember that it's 180 and our number of triangles. The other thing that we want to think about is what happens in a regular polygon. Now let's remember that regular polygons will have congruent sides and they have to have both, congruent angles. So congruent sides and congruent angles. Now, that means that if a polygon is a regular polygon, if you know what all the angles are going to add up to, and all the angles are supposed to be congruent or equal, then you can easily find the measure of a single angle. So that's what this last formula here at the bottom is going to be. How could we find the measure of one interior angle if we knew the polygon was regular? What we could do is we could find the sum of the interior angles using the formula that we just developed and divide it by its number of sides. Now, if you like that in a more formal sense, it would look like this. Remember, our sum formula was 180 times n minus 2, and that would divide by n being our number of sides. Now, the last thing that we're going to do is we're going to come back here to this left side, and we're going to look at exterior angles. Now, we need to remind ourselves, what is an exterior angle? An exterior angle is found by simply extending any side in the polygon, and it doesn't matter what direction you extend it. So if I extend this side to the right, that's going to form an exterior angle. I could extend this side in the quadrilateral also to the right and create an exterior angle. I could do the same thing on my pentagon here. I could extend and get an exterior angle. I could extend and get an exterior angle. Now, if we want to understand the sum of the exterior angles, we really want to be able to look at this in terms of what is called a set of exterior angles. And when we do that, we want to extend all the sides in the same direction. So you can see I've drawn in a set here, and I've extended them all in the same direction. And what happens is it creates this little pinwheel effect where none of the extensions would run into each other like they would have up above on those. Now, we've created all of these exterior angles, and what we want to do first is find what would be this last angle here. And what we're going to do is we're going to count up how many sides we have. We've got 1, 2, 3, 4, 5, 6. So we have a 6-sided polygon, we have a hexagon, and we know from what we just did, let me slide this down here, we know that from what we just did, all the angles inside this hexagon should add to 720 degrees. So if they're all going to add to 720 degrees, we could fill in our last angle. So let's give ourselves a reminder here. Our hexagon is going to equal 720. If we know all these individual ones, our last one then would be 100 degrees. From there, what we can do is we need to recognize that an interior angle and an exterior angle are going to be supplementary. We can fill that in down here as well. So we're going to fill in that the interior and the exterior angles are supplementary. And then we're going to actually go through and calculate those. So you could pause the video and try to calculate them and check. I'm just going to fill them in. Our exterior angles would be 35 degrees, 19 degrees, 109 degrees, 49 degrees, and 80 degrees, and one more, I almost missed it, 68 degrees. Now, if you bust out your calculator real quick and you add up all of the measures of these exterior angles, since we've got our complete set, what you will find is they do in fact add to 360 degrees. This is in fact always going to happen, and when you're in class, I'm going to show you a little video of how this works, a little hands-on to help you see that yes, in fact, all the time on any polygon, it doesn't matter how many sides, the sum of the exterior angles will always be 360. So just like we did with our interior angles, we do want to consider what would we do for a regular polygon to find one exterior angle? And what we could do is we could take the sum of the exterior and divide it by the number of sides. Or in a formula sense, although it feels like a really basic formula, one exterior angle, again, this is only on a regular polygon, would be 360 divided by n. Now, we're going to do a lot of problems with this in class, but for right now, I just want you to get comfortable with these formulas and kind of commit these formulas to memory.